Hey guys, today's video we're going to talk about sampling design. By the end of the video, you should be able to compare and contrast various types of sampling design, giving the advantages and disadvantages of each. You should be able to discuss and describe how you're going to set up a simple random sample using technology, slips of paper, coins, random digit tables, and you should also be able to identify which sampling method is used in an observational study or sample survey. So let's get started. Today's lesson is on sampling design. The goal of sampling is that we have a large population of interest that we want to know something about. And usually we can't go and sample this population directly. For example, we might be looking at the population of sharks living in the Pacific Ocean. Obviously, we can't blow a whistle and get all the sharks to line up and then interview them or take measurements about them. So this is a population of interest that we can't sample the entire population directly. So instead what we do, if we're trying to find a parameter, some number or variable that we're estimating or analyzing about a population, we will take a sample. And our goal when taking a sample is that it's representative of the entire population. So we're going to sample, we might sample more than once, and from those samples we are going to calculate a statistic, a variable that represents the sample. So the very first part of what we're doing in statistics and what we're going to talk about today is how we take a sample and how we sample effectively and appropriately. Later in this course, we're going to use the statistic from our sample and we're going to use it to infer something about the population. We're going to predict, do a hypothesis test, or build a confidence interval so that we can predict the true parameter for a population. Today, let's talk about actually gathering data. So how do we gather data? Well, we have several different options. We can take a census. We can do what is known as a sample survey. This incorporates either surveys, opinion polls. You might see those a lot on the internet today, or even call-in voting shows. That may be something that you've seen. Somebody asks you to vote for your favorite performer on a television show. You might be interviewed, or there might be what we call an observational, retrospective, or prospective study. In a study, we're just sitting back and analyzing something that's going on. We can also do experiments where we're actively involved in controlling or looking at a process and trying to figure out what explanatory and response variables there are. Now, we said that we could do a census where we interview everybody in a population. In the United States, we do attempt that every 10 years. But why would we not use a census all the time? Well, there's a couple of different reasons. Often, it's not accurate. If I took a census right now about all the people living in the United States, by the time I compiled the data, people could have moved away, people could have passed away, and new babies have been born. So the census is not always accurate. In addition to that, it's very expensive and time-consuming to produce. So if we're going to spend a very long time analyzing the results and even compiling the data, and we know that it's not very accurate, it's usually not an effective method to use. And then we also have an impossibility with sometimes doing a census, like I gave you the example earlier with the shark study, or with a study of like deer in the wild. If we want to know about the average size of a white-tailed deer in Texas, we certainly can't do a census and interview all the white-tailed deer or measure all the white-tailed deer in the state. If we have something that is known as destructive sampling, it's also not possible that we do a census. You'll see destructive sampling when we talk about crash testing a car. If you drive a car, it has a crash safety rating. Well, they didn't crash your car to get the crash safety rating. Instead, they took a sample of, let's say, Fords, crashed them, did a study, and determined that that sample of cars, that all Fords would crash similarly to the sample of Fords that were crashed. If we did a census, we would crash every single car that's produced, and then there wouldn't be any cars to buy. And another example of this might be food testing. If we were analyzing food that was produced and we were testing it, to do a census would mean to test every single piece of food that's produced. And again, we would have nothing left to sell. So a census is not really feasible in most cases. Instead, we use statistics to take a sample and use that sample to determine something about our population of interest. Sample surveys, also known as studies or observational studies, depending on what textbook you pick up or what you're reading, are really an organized plan. We're using them to gather information about a population done in such a way that the sample represents the specific population and we're not disturbing the population or destroying it in the process. You might hear this be called a sample survey or an observational study, again, depending on your professor, your teacher, or which textbook you happen to be using. When we take a sample, this is a subset or part of the population that we're trying to gather information about. And then we're going to use inference later in this course to use that sample data, the statistic that we've calculated, to generalize or draw conclusions about the population of interest based on our sample. So it's very important that our sample is a good representation of the population so that we are able to accurately predict or infer something about our population. So it's important that we really study how to take a sample and how to set up an observational study effectively. We do this with various methods, and these are called sampling designs. We have a number of different tools that we can use in our tool chest. A sampling design is simply the method we're using to choose the sample from our population. And this is the heart of what we're talking about today. We are going to examine various different sampling designs. We're going to learn how to set those up and how to choose samples from our population using various methods. And then we're going to go back and we're going to analyze the advantages and disadvantages and compare and contrast each of those methods. Now, before we begin, one other thing that we need to talk about is called a sampling frame. A sampling frame is simply a list of every individual in the population. It's possible that we have a list of every individual in the population for some populations. Let's say if you are at a high school, we could come up with a list of every single student registered to attend that high school. In that case, we can come up with a sampling frame. That allows us to use some sampling methods that require a sampling frame. Again, if we go back to the shark study, it's not possible that we have a list of every individual shark living in the Pacific Ocean. So in that case, we're not going to be able to use a sampling method that requires a sampling frame. We're going to have to pick a different sampling design. So it is possible that we don't have a list. It is possible that we do. How do we sample well? Well, we could sample poorly very easily. We could do what's called a convenience or judgmental sample. We could just walk up to somebody that's smiling at us in the hallway and ask their opinion on a subject. But that isn't sampling well. We've only picked people that we know or that might be friendly. So now we're going to investigate how we can sample well and effectively. The first thing we've got to make sure of is that we use random chance to choose our sample. We can't sample people that we like or that we're friends with. We can't sample friendly people in the population or people that we think might give us the answer we want. Instead, when we're setting up an observational study, we have to sample in a method that utilizes random chance to choose the sample. When we say random in statistics, we really mean due to chance. And we can use randomization to choose our sample by using things like coins, by flipping a die or a pair of dice. We can use slips of paper to pick a random sample. We can use a random number generator on our calculator, or we can go to a website like random.org, or we can even use a random digit table. Those can be found in the back of almost every statistics textbook, and if you Google random digit table, you can find pages and pages of random digit tables to use as well. Now, we use the TI-Nspire graphing calculator in the class that I teach, and it has a random number generator. If you use the TI-Nspire, the next few steps might help you when you go back and use your calculator. The first thing I would recommend when you're using your calculator is to seed your calculator. Your calculator uses an algorithm to pick a random number. If we all use the same calculator without seeding it, we might get the same random numbers because we're using the same algorithm. It doesn't really feel very random if we're getting the same numbers. So if you seed your calculator, you've basically told your calculator to begin somewhere else along that algorithm. So to seed your calculator from the home screen, you're going to create a new document and you're going to pick your general calculator screen. From the calculator screen, you're going to select Menu. You're going to pick the Probability menu, your Random, and then Seed on your calculator. Your calculator will say Random Seed and then ask you for a unique random number. This can be your driver's license number, your phone number, your student ID. Enter a number that's unique to you and press Enter. Your calculator will say Done, and now you've seeded your calculator so that it will give you random numbers. To go back and generate a random number, again, from the main calculator screen, we're going to go back to Menu, Probability, and Random, but now we're going to select a random integer. The random integer function will allow us to pick a random number between two endpoints. So on your screen, you'll see random integer. You're going to put 1 if that's your starting number, comma, the last number in your population. Okay? You can hit enter, and then it will give you a random number. You can hit enter repeatedly and can continue getting random numbers. You can also go up using the up arrow, highlight this random integer command, and then go back and edit it if you change the number of individuals in your population. All right, so let's get started choosing a simple random sample. The very first type of random sample that we will encounter is called a simple random sample. When we're picking a simple random sample, we basically have a large population of interest we want to know something about, and our goal is to randomly pick a sample that is representative of that large population. Again, our sample happens to be a subset of the population. Now, there is a definition that we've got to make sure that we adhere to for a simple random sample, also known as an SRS. Our definition says that a simple random sample consists of n individuals. N just represents your sample size. If we're picking a sample of size 10, this would be 10 individuals chosen from a population in such a way that we meet some criteria. The first is that every individual has an equal chance of being selected. Well, if we number everybody in our population, let's say from 1 to 100, and we use a random integer to pick 10 unique random numbers, we ignore repeats, then every individual does have an equal chance of being selected. The second criteria we've got to make sure we meet is that every set of n individuals has an equal chance of being selected. This is a little harder to grasp. This means that every set of, let's say, 10 individuals has an equal chance of being selected. In other words, just due to random chance, it's possible that I pick just 10 boys in my sample, or that I pick 3 girls and 7 boys, or that I pick only 10 girls. All of those are possible just due to random chance if I have selected a true simple random sample. Here's an example. Let's say we wanted to take a simple random sample of students at a high school. Assume that we have 1,100 students at our high school, and we're going to write down on a piece of paper how we would take a simple random sample of 100 students out of those 1,100. Now, I really want you to practice this. So real quick, pause this video and grab a piece of paper and actually write down a couple of sentences explaining in detail how you would pick a simple random sample. The burden of proof here is that you have to do this in enough detail that I could read your paper and do exactly what you've done. So go ahead and press pause now and then come back when you've got your answer. All right, hopefully you're back and you've got an answer. There's a few ways that we could do this. I'm going to give you 3 examples. The first example that you could have said is that you could have used a random number generator. In this case, we would number our students from 1 to 1,100. We'd use a random number generator to select 100 unique random numbers, ignoring repeated numbers. That way, we've chosen a simple random sample using some technology. Or you could have said number 2, that you number students from 1 to 1,100, which is the total in our population. You place the numbers on slips of paper. You place the slips of paper in a hat. You mix them up and randomly select 100 unique random numbers from your hat, of course, ignoring repeats. The last option is that we number students from 0001 to 1100, and we use a random digit table to select 100 unique 4-digit numbers, ignoring repeats. Now, I'm pretty particular there. We numbered our students from 0001 to 1100. The reason is that we have a 4-digit number. So in order to select anybody that has a 4-digit number, we have to pick digits 4 at a time. We also need to say there that we are going to ignore numbers like 0000 and any number over 1100 because those don't represent any individuals in our population. So as you can see, there's several different ways to pick a simple random sample, but you really need to be careful and concise and detailed in the way you explain how to select a simple random sample from a population of interest. We can also use a random digit table. If you don't have access to a random number generator on a calculator, or sometimes I might give my students a random digit table so I can make sure they're doing this correctly and effectively, a random digit table is a great way to select a simple random sample or a random sample from a population. So if we're selecting from a random digit table, it's first important to understand truly what a random digit table is. In a random digit table, every entry or every number in the table is equally likely to be any of the 10 digits. Those are the digits between 0 and 9. So each of the individual digits has an equal likelihood of occurring. Basically, we've randomly selected numbers and we've listed them on a table. Each of the digits are independent of one another, so it doesn't matter that we've already selected a 0. We're not ignoring repeats. We could have a string of zeros or a string of 9s in our random digit table. And then we're going to read numbers from a random digit table in a method that we've described so that we are picking a simple random sample. So here is an excerpt of a random digit table. This is actually from the textbook I use in my class. And if you notice, the first column of the random digit table is actually our rows. So you see 1, 2, 3. Those are actually not unique random numbers. That just represents row 1, row 2, and row 3. When we're utilizing a random digit table, we can use the random digit table and we can read the numbers horizontally, either left to right or right to left. We can read the numbers vertically, top to bottom or bottom to top. We can also read the numbers diagonally, top to bottom, bottom to top, left to right, right to left. We just have to describe how we've picked those random numbers. So let's go through an example and let's use a simple random sample, or let's use a random digit table to pick a simple random sample from a population. In this example, I'm going to assume that we have 20 people in our class or our population, and we want to select a sample of 5 individuals. Well, if you notice, the individuals are numbered from 1 to 20. If I'm only selecting digits 1 at a time, I will only ever be able to pick students 1 through 9. So I need to pick my digits 2 at a time, and so Elizabeth wouldn't be numbered digit 1 when I select her. She would be 0, 1 as we read our random digits in the random digit table. So what we're going to do is we're actually going to select our digits, double digit numbers. We're going to select 2 digits at a time from our table, reading from left to right. We're going to ignore the numbers 0, 0 because that doesn't represent any person in our population. And when we pick 2 digits, we also have the numbers 21 through 99 that we might select. We're going to ignore them because they don't represent any students in our population. And we're also going to ignore repeats because we want 5 unique individuals to be selected. And our stopping rule, we need to talk about when we're going to stop. So we're going to stop when we have 5 people in our sample. So let's try this. We're going to circle the 2 digits at a time we use, and I'm going to cross them out if they're not utilized or if they're not meaningful for my sample. So here we go. The first 2 digits that are selected are the numbers 91. Well, those don't represent anybody in our population, so they're actually useless in this example. We're going to cross them out and keep going. The next 2 digits represent 62. Again, outside of our population, we're going to keep going. 93 is an ignore. And 04 actually represents a person, so we've selected Dave for our sample. At this point, you may want to pause the video and go ahead and select 5 people, and then come back and pick up the video and make sure you've selected them correctly. All right, if you're back from pausing, we're going to keep selecting 2 at a time. We're going to ignore anybody over number 20 because they don't represent anybody in our population. So our next student selected is Hunter. Now, if you notice, we're at the end of a row. That doesn't mean we ignore a digit. We actually just take 2 digits at a time, so our next sampled person will be student number 16. Ellie is in our sample. 42 is ignored, 51, 19, we've selected Paul, 74 we ignore. We've selected 19 again, but we said we want 5 unique individuals, so we ignore repeats. We select then student number 7, and we have got the 5 individuals from our population to make up our sample. So our random sample are students 4, 11, 16, 19, and 7. This is how we use a random digit table to select a simple random sample. Each of the individuals had an equal likelihood of being selected. It was possible that I got all boys or all girls in my sample just due to random chance. Now, simple random sample is only one way to select a random sample from a population. There are other ways as well. Let's talk now about a stratified random sample. To set up a stratified random sample, first we break our population into what are known as stratum or strata. So in this case, we have stratum 1, stratum 2, and stratum 3. We don't randomly select individuals for our strata. We're actually selecting individuals for each strata so that they have something alike within that strata. We want our strata to be as homogeneous as possible, and we want to classify them based on some characteristic in the strata that we think will have an impact on the results of our study. Now that we've gotten them broken into subgroups that we think will impact our study, we select a simple random sample from each of the strata, and we take the individuals from those simple random samples and they become part of our overall sample. And then we use this sample to analyze and predict something about our population of interest. Now, when we're doing a stratified random sample, we group our population into these homogeneous groups called strata. That again is not random. We've deliberately picked them based on some homogeneous characteristics. We also then choose a simple random sample from each of the strata, and we combine those simple random samples to form our sample that we're going to analyze that we'll calculate a statistic from as well. Make sure that when the strata are divided, that the individuals in each strata are similar and the different strata are different from one another. So what we typically say is that they're the same within and different between. So let's say we want to sample from a population again at the high school that we were talking about earlier. How would we take a stratified random sample? Well, at a high school, our population is already broken into homogeneous groups by grade level. So if we were trying to take a stratified random sample from a population, we could do this based on grade level. So to take a stratified sample of size 100 from our population at Boerne High School, we could first divide the BHS students into grade levels, 9th, 10th, 11th, and 12th. Once we break them into grade levels, we could take a simple random sample of students from the 9th grade, another SRS of students from the 10th, one from the 11th, and one from the 12th. So we have 4 different simple random samples from each of the strata. We combine those so that we have 100 students chosen for our sample. We have an overall sample size of n equals 100. If we do that, we've taken a stratified random sample of students at BHS. In addition to SRS and stratified random samples, we also have what is known as a systematic random sample. In a systematic random sample, we pick a certain person in our population randomly to begin with, and then we use the system to pick the next person in our population, let's say every second or third or seventh person in our population. So we randomly select where to begin. That person is the first individual chosen for our sample, and then we pick, let's say, the second or every other person after that, and each of those individuals that are selected become individuals that are a part of our observational study or our sample survey. All of those individuals make up our sample that we're going to use, that we're going to analyze and calculate our statistic from. So if we're picking a systematic random sample, again, we're doing this in such a way that we randomly decide where to begin. We have to randomize where to begin so that we have a random piece of our sampling method. After that, we can select maybe the 5th person or 10th person or every 100th person after that. So we're following a systematic approach to represent or to select the rest of our sample. All of the individuals selected are part of our overall sample. So if we're back to our students at BHS, let's say we have 1,200 students and we want to take a systematic sample. We could select a random digit, let's say between 1 and 12. This is our starting point. We don't select that randomly. We would either pick a random integer from 1 to 12 using a random number generator on our calculator, or we could put the digits or the numbers 1 through 12 on slips of paper, place them in a hat, and mix them up and randomly select where to begin. Once we've randomly selected our starting point, we use a systematic approach, and maybe we'll select the 10th person after that to complete our sample. We'll continue until we either have enough people in our sample or we've selected the sample that we're interested in. So a systematic random sample uses a random place to begin the sample and then a systematic approach to continue. All right, the next type of sampling that we're going to use or talk about today is known as a cluster random sample. Now in a cluster, we have clusters of individuals usually broken up based on like a location where they live in a city, or maybe if we're looking at a factory, this could be which assembly line they come off of or which line they are at a factory that's producing, let's say, semiconductors. So in a cluster sample, what we do is we randomly select a cluster. In this case, we'll randomly select cluster number 3, and then we'll randomly select the cluster, and then every single individual in that cluster becomes part of our sample. Or we would randomly select cluster number 6, and then everybody and individual in cluster number 6 becomes part of our sample. So here we've randomly selected 2 clusters, and all the individuals in those clusters are part of our sample. We would have a sample size of n equals 6. We could again do this with our high school example. In a cluster random sample, the population is usually already divided for us into clusters or groups of individuals located near one another. Zip code, street you live on, class period that you share at a high school, some sort of cluster or group of individuals, or again, like we said, assembly line at a plant. We randomly select clusters based on a simple random sample. Here we could have numbered the clusters from 1 to 6 and randomly selected 2 clusters that are unique using a random number generator. Then we sample everyone in the selected cluster. If we give an example again of Bernie High School students, we could cluster sample all of the students at Bernie sample of students at Bernie High School as well. Remember, our goal here is picking a representative sample of the population, but a sample or subset that's smaller than the population. So at BHS, we could maybe list all of the second period classes. We could randomly select 4 of the second period classes, and then we could go into those classes and sample all of the students in those classes to pick what is known as a cluster random sample. Now, sometimes, and this is really beyond the scope of the class that we're looking at today, but sometimes it's possible to pick what's known as a multistage random sample. We might want to use random samples to basically take a very large population and break it into smaller and smaller and smaller samples until we get something that's small enough that we can go ahead and analyze the results. And in this case, we call that multi-stage random sampling. We're just going to select smaller and smaller groups at each stage in our sampling process. And we're going to take a random sample at each stage and then continue to get a smaller group. So again, we could look at our high school example. Let's say we wanted to take a sample of 30 students at BHS, and we wanted to do this with a multi-stage sample. We could go ahead and divide our second period classes into strata. We could have AP level classes, pre-AP level, and regular or on-level classes. We could then randomly select 2 second period classes from each strata. So 2 second period AP, 2 second period pre-AP, and 2 second period regular. We've now broken into smaller groups, so we've got 6 different classes we've sampled. Well, from those 6 second period classes, we could randomly select 5 students from each class. So from one of our second period AP level classes, we could do an SRS and pick a simple random sample of 5 students. We could repeat this for every class and get 5 students from each of the classes for a total of 30 students. In that way, we would have selected a multi-stage random sample. So we've quickly gone over the different types of sampling methods that we'll use in this course, but which one do you use and when do you use them? Well, obviously there are some advantages and disadvantages to using each in the real world, and so we're going to talk about those. Let's compare and contrast when we might use a different type of sampling method. So we're going to start over with a simple random sample that we conveniently like to call in stats an SRS. There are both advantages and disadvantages to each of these sampling methods. The first advantage of an SRS, or a simple random sample, is that it's unbiased. If we're randomly selecting individuals from a population, and we're not just picking our friends or people that are convenient, we have picked an unbiased sample from our population, which is really key if we're going to be able to analyze any meaningful results. As you saw earlier, an SRS is also very easy for us to conduct. And in the real world, if it's easy, it also means that it's cost-effective or inexpensive. The primary disadvantage of a simple random sample is that we really have to have a sampling frame. We have to have a list of every individual in our population so that we can use slips of paper, random digit table, or random integers to select them. So if we're again trying to sample sharks in the Pacific, we can't use a simple random sample to do that. We also have a large variability or variance in our simple random sample when we're calculating variance. And again, later in this course, we're going to use our sample to predict something about the population. If we have a lot of variability from one sample to the next, or we have a large range or spread of values within our sample, we start to be concerned about using inference or we may have a problem or get something wrong if we use our sample to predict something about our population. Or maybe we just would prefer something with less variability. If we have a simple random sample, we also had talked about earlier that our sample may not be representative of the population. For example, if we're trying to do a political poll or study and we take a simple random sample, it is possible that that sample just got only Democrats or only Republicans on that particular day. Well, we know that the population is not made up of only Democrats or only Republicans, so in that way, the sample might not be representative of our larger population. We also have advantages and disadvantages when we take a stratified random sample. Again, just like with an SRS, a stratified random sample is unbiased, which is key. One of the primary reasons we might want to stratify when sampling is that in a stratified random sample, we have more precision than we did with a simple random sample, meaning we should see less variability in our sample, and we should see less variability than we had with a simple random sample or an SRS. If the strata naturally exist or are already divided, our cost could be reduced, and this isn't going to be a more costly method either. Now, again, just like an SRS, we still need a sampling frame, which is a primary disadvantage of using a stratified random sample. It also can be very difficult if our strata are not already divided, because in order to divide our population into homogeneous groups for our strata, we need to know something about the population that we think will affect the results of what we're looking at. So if we don't already know that, or it might be very time-consuming or troubling to break people into those strata, then it could be difficult and be a disadvantage of our stratified sampling design. And if we use formulas for standard deviation and confidence intervals, those get to be quite complicated, and those are really outside of the scope of this course, so we won't be calculating a formula for standard deviation of a stratified random sample in this class. We also talked about a systematic random sample, where we randomly selected where to begin, and then we picked a system to select the next person after that to get our sample. Well, a systematic random sample also has its own unique advantages and disadvantages. Just like the two methods we've talked about already, primarily one of the big advantages of systematic random sampling is that it is unbiased because we've used randomization to pick our sample. The other key, though, is that a systematic random sample does not need a sampling frame. I don't have to know how many sharks are in the ocean. I don't have to know how many people are coming to tonight's concert. I don't have to have a list of all those individuals. I can use a systematic random sample without a sampling frame for my population. My systematic random sample also guarantees that I will have my sample spread across the entire population. I've picked every 10th person that I encounter. I've picked every 100th person that enters the stadium. It is very efficient and inexpensive. I can literally pick a random person to begin with at a Spurs game, let's say. I can have my surveyor stand at the entrance to the game, and we could survey, let's say if we randomly select the 10th person, and then we could survey every 100th person after that. It's very efficient and inexpensive. Now, when we're calculating some values for a systematic random sample, the formulas get very complicated very quickly. And we also notice that our results can be confounded by trends or cycles. For example, let's say we randomly select a day in the month to look at temperature, and then we select or maybe the moon phase, and we look at every 10th day after that. There could be a trend or a cycle that we are not seeing or that we are seeing that maybe is confounding the actual things that are going on in our sample. We don't really realize the true impact on our sample because we've been confounded by a trend or a cycle that may be muddying the waters or making us think that there's a pattern that's different than what really exists. And like I stated already, the formulas are not just large, they're quite complicated, and also will be outside of the scope of the course that we're looking at right now. The last type of sampling we talked about was cluster random sampling. Again, cluster random sampling is unbiased because we've randomly selected clusters to be in our sample. When we do cluster random sampling, it's also very cost effective, and our sampling frame is not necessary in order to do a cluster random sample. We're going to randomly select a cluster, and then we sample everybody within that cluster is already in our sample. We wouldn't need a sampling frame. Now, it is possible that the clusters might not be representative of the entire population. If I'm picking clusters based on geography, and I pick a street randomly, and I sample everybody on that street, we know that everybody on that street is living in a similar subdivision, a similar neighborhood. They may have similar characteristics that make that sample not representative of the overall population of interest that I'm trying to study. And again, the formulas are complicated and really outside of the scope of the formulas that we're going to calculate in this class for variance and standard deviation. So now we've taken a look at the different types of sampling design, the advantages and disadvantages of each of those sampling designs or methods. I want to see if you're able to identify a sampling design in an observational study or sample survey. So we're going to look at 3 examples and see how well you do at identifying the types of sampling design. Let's go. Here is our first example. Let's say Nordstrom wants to better understand their customer style preferences. They do have a list of all Nordstrom cardholders. They number the cardholders, and using a random number generator will select 500 unique random numbers. They send questionnaires to the corresponding cardholders. So take a minute to reread this, pause the video here, and try to determine whether this is an SRS, a stratified, systematic, or a cluster random sample. I'll wait while you do this. All right, let's see if you got it right. Hopefully you paused the video, reread the question, maybe looked at your examples to see, or looked at your definitions to see. If you said that this was a simple random sample or SRS, you are correct. Great job. Let's keep going. Let's say over a holiday weekend, the San Antonio District Attorney is worried about the number of drunk drivers on the road. He selects 4 locations around the city where there are a high number of accidents and wrong-way drivers on other weekends. The police set up a stop in each of these locations and gives each driver that comes through their stop a breathalyzer to see if they're driving under the influence. Take a minute, look at your definitions again, pause the video, and determine what type of sampling design was used here. All right, let's see if you got it right. Did you say that this was a cluster sample? If so, you got it correct. This was cluster sampling because we selected 4 locations around the city, hopefully randomly selected 4 locations of all the locations around the city where there are a high number of drunk drivers or accidents or wrong-way drivers. And then we're sampling each and every person at that location that goes through that stop. That's what makes this a cluster sample. All right, last one. The TSA is tasked with keeping U.S. airports safe. In an effort to increase security without increasing wait time for passengers, the TSA supervisor selects a random number between 1 and 10. They select that passenger to go through extra screening, then they select the 20th passenger after that one, and continue selecting the next 20th passenger throughout the day to complete the more time-consuming, intense screening process. Last one. Pause the video and tell me what you think. All right, did you get it? Let's see. This was a systematic sample. If you said that, you're right. If you got all 3 right, you're doing great. So what's up next for us? Well, in this video, we looked at sampling designs. Hopefully at the end of this video, now, you should be able to identify the sampling design that's used in an observational study or sample survey. I also hope that you can describe for me how to set up a simple random sample, stratified random sample, systematic or cluster random sample to decide a random sample from a population. And hopefully you can list the advantages and disadvantages of each of these different designs and compare and contrast which might be best given a particular set of circumstances. After today's video, the next video will be on bias. So check back soon for a video on bias. Happy studying in statistics. Bye.